Namaskaram. In last two classes, we have derived wave equation and three possible separable solutions. Also, we have seen that 1 and 2 are not consistent with our wave problem. In this session, we will solve this problem using the third solution derived in last class. Okay, let's start. This is the mathematical version of our wave problem. That is, we have to find displacement yxt. We know that yxt satisfies this wave equation with these three conditions, two boundary conditions and two initial conditions. So we are going to solve this problem using our third separable solution, that is yxt equal to a cos px plus b sin px into c cos pct plus d sin pct. First we are going to apply these boundary conditions on our solution. When x equal to 0, left hand side become y0 t, that is 0, and right hand side become, when x equal to 0, cos 0 is 1 and sin 0 is 0. So this term become a. Okay. So when x equal to 0, this equation become 0 equal to a times c cos pct plus d sin pct for all t. As similar to the previous cases, this term is non-zero. If this term is 0, then this is 0. That means yxt is throughout 0. That means there is no displacement. So this implies a should be 0. Okay. Substitute a equal to 0 in this equation. Then we get yxt equal to b sin px into c cos pct plus d sin pct. If we multiply this b into the bracket, this term is bc and this term is bd. Here b and c are arbitrary. Okay, so bc also arbitrary. So we denote that arbitrary by e. And similarly, b and d are arbitrary. So bd is also an arbitrary. We denote it by f. So this expression become yxt equal to sin px into this bc become e. So e cos pct plus f sin pct. We denote this equation by 1. Okay. Next we are going to apply the second boundary condition. We substitute x equal to L. When x equal to L, the left hand side become ylt, that is 0. Okay. What about the right hand side? Right hand side is sin pl. So 0 equal to sin pl into e cos pct plus f sin pct for all t. As similar to this case, this is non-zero. If this is 0, then our solution throughout 0. So this implies sin pl equal to 0. Okay, sin pl equal to 0 implies pl equal to n pi for all n belongs to z. Z means set of all integers. So this implies, so p equal to n pi by l, where n is an integer. Substituting p equal to n pi by l in equation number 1, then we get yxt equal to sin n pi x by l, because our p is n pi by l, t cos n pi ct by l, f sin n pi ct by l. This is true for every integer n. So equation 2 is not a single solution, it is a collection of solution, because whatever be the value of n, this gives a solution. Suppose n equal to 0. If n equal to 0, this becomes sin 0. Sin 0 is 0. So when n equal to 0, yxt become our trivial solution, 0 solution. Okay. We are interested only on non-zero solutions. So we throw out the case n equal to 0. So these are the non-zero solutions for all integers except 0. Also, these arbitrary constants are different for each n. We rewrite this equation number 2 as yn of xt is equal to sin n pi x by l into this an. So this arbitrary constant depends n. So replacing this e by an cos n pi ct by l plus and bn sin n pi ct by l. Okay, for all n belongs to z minus 0. One property of linear homogeneous equation is, if y1 and y2 are two solutions of a linear homogeneous equation, then their sum y1 plus y2 is also a solution of linear homogeneous PDE. Okay, so our wave equation is a linear homogeneous. So if yns are solutions, so their infinite sum, their sum is also a solution. This become yxt equal to, so most general solution yxt equal to sigma n belongs to z minus 0 sin n pi x by l into an cos n pi ct by l plus bn sin n pi ct by l. If you expand this bracket, then we get yxt equal to like this. Okay. Another important thing is, you suppose n equal to 1. Suppose n equal to 1. Then what is the term corresponding to n equal to 1? And similarly, suppose n equal to minus 1. Then what is the term corresponding to minus 1? And this is equal to cos minus theta is cos theta. So this becomes cos pi ct by l, similar to this term. This is sin minus theta form, that is minus sin theta. Okay. So the first term is, this is minus of sin, this also minus of sin. So minus minus plus. So this become. Next we comparing these two terms. This is corresponding to n equal to 1. This is corresponding to n equal to minus 1. Okay. These two terms are same, right? Similarly, these two terms are same. You can add the terms corresponding to n equal to 1 and n equal to minus 1. Then what happened? Then we get so this is the sum of the two terms corresponding to n equal to 1 and n equal to minus 1. Okay, it is clear that here a1 and a minus 1 both are arbitrary. Okay, so we can replace this difference by another arbitrary, that is a1. Similarly, b1 and b minus 1 are arbitrary, so you can replace this quantity by some b1. Similarly, if comparing the positive and negative corresponding terms, that means the terms corresponding to 2 and minus 2 and terms corresponding to 3 and minus 3, like that. Okay, then we get yxt equal to sigma n equal to 1 to infinity an cos n pi ct by l sin n pi x by l plus bn sin n pi ct by l sin n pi x by l. Then what is an and what is bn? What is an in terms of this capital N and capital Bn? And similarly, what is bn? Here an and a minus 1 are arbitrary, so their difference is also arbitrary, that is replaced by small I. Similarly, bn and this b minus n are arbitrary, so their sum is also arbitrary, so we are replacing that quantity by small bn. This is the non-zero solution derived from our third separable solution. This is the justification for the statement mentioned in the previous session. Okay. Here sin n pi x by l is common, so you can take outside. We can find this an and bn using initial conditions. So first we are going to apply this initial condition, that is initial shape. We substitute t equal to 0, then left side become yx0, and we know that yx0 is f of x. When t equal to 0, this term is 1 and this term is 0, sin 0 is 0. So this expression become an. So this infinite series becomes sigma an into sin n pi x by l, right? This means f of x in terms of sine. Are you familiar with such expression? Yes, this is the Fourier sine series of f of x in the interval 0 to L. So what is an? What is the Fourier coefficient? N is 2 by L 0 to L f of x sine n pi x by L dx. We have one more initial condition, that is initial velocity. Partial dy by dt at t equal to 0 is g of x. So g of x is none. Okay. So first we consider the derivative of our solution. Okay, so this is the derivative with respect to t. Then you substitute t equal to 0. So left hand side become g of x. What about the right hand side? When t equal to 0, sin 0 is 0 and this time is 1. So cos is 1. So this become bn. Okay. So when t equal to 0, this expression become g of x is equal to sigma n equal to 1 to infinity bn times n pi c by l into sin n pi x by l. So this is the Fourier sine series of g of x, right? So this bn into n pi c by l is the Fourier coefficient. Okay, so what about the Fourier coefficient? Here the Fourier coefficient is Bn into n pi c by l. That is equal to 2 by l 0 to l g of x into sine n pi x by l dx. And this implies Bn is equal to like this. Now the problem is completely solved. So this is the solution of our verb problem. The solution is called the Fourier series solution. Okay. So yxt equal to like this, where an is given by an and bn are given by these formulas. Consider a problem. A tightly stretched string of length 60 cm is fastened at both ends. The initial shape of the string is given by f of x equal to 60x minus x square. If it is released from this position, find the displacement yxt. Okay, so what are the given conditions? So the given conditions are the length is 60, so fixed at 10 points, so at 0 and 60. So here our L is 60, right? And initial shape of the string is given, so f of x is given, that is 60x minus x square. And it is released from this position, just released. So what about the initial velocity? Yes, it is 0. That means g of x is given, that is equal to 0. These are the given conditions, y0t equal to 0 and y60t equal to 0. And initial shape is 60x minus x square and initial velocity is 0. And we know that this is the general solution of the verb problem. We are simply replacing L by 60. Okay. And you can easily find an and bn using our Fourier coefficients. So what is an? We can evaluate an using this formula, replacing L by 60, and similarly bn's by this formula. So here g of x is 0, initial velocity is 0. So what about this integral? Whatever the value of n, this integral is always 0. This implies all the bn's are 0. Next we have to find an's. By substituting f of x as 60x minus x square. 1 by 30 integral 0 to 60. 60x minus x square into sine n pi x by 60 dx. Next we are going to integrate this using general rule of integration by parts. That is integral uv dx is equal to u into integral of v1. We denote lower suffix for integration, upper suffix for derivative, minus u1. So u1 stands for derivative of u. v2. So what is v2? v2 is the integral of v1. Okay. And plus u2 v3 minus plus etc. And this formula is applicable only when the derivative of first term should 0 after finite number of steps. Okay. So applying this formula to this equation, here we are treating this as our u, this as our v. So this become 1 by 30. Yes, u is 60x minus x square and u into v1. v1 means integral of v. So what is integral of sine? That is minus cos n pi x by 60 divided by n pi by 60. Okay. Then minus u dash. This is our minus sign. U dash. Derivative of this expression. That is 60 minus 2x. Right. Then v2. What is v2? v2 is, you should remember, v2 is integral of v1. This is our v1. This entire thing, including this minus. Okay, this is our v1. So what is the integral of v1? The integral of cos is sine. There is a one minus sign. So minus sine n pi x by 60 divided by n pi by 60. Already one n pi by 60 is here. That's why this is n square pi square by 60 square. And what about the third term? Third term is plus. Yes, plus u2. u2 means second derivative of u or derivative of u1. This is our u1. Okay. So what is the derivative of 60 minus 2x? That is minus 2. And v3. What is v3? v3 is the integral of v2. This is our v2. Right. Including this minus. This full quantity is our v2. Okay. So integrate this v2. So that is again integral of sine is minus cos. So minus minus this become plus. That's why this is cos n pi x by 60 by n cube pi cube by 60. Okay. Then lower limit is 0, upper limit is 60. If you substitute upper limit and lower limit, then we get like this. Because when x equal to 60, this is 60 square minus 60 square. So this is 0. And in second term, when x equal to 60, this becomes sin n pi. And sin n pi is 0. Okay. And the last term is minus 2. Yeah, minus 2. its reciprocal is this one, and this become cos n pi, and cos n pi is minus 1 raised to n. Minus, then we substitute lower limit 0. When x equal to 0, this expression is 0, and here sin 0, so this one also 0. When x equal to 0, this is 1. So minus 2 times its reciprocal, that is 216,000 by n cube pi. Okay. Okay, by simplifying this, we get 14400 by n cube pi cube into 1 minus minus 1 raised to n. This term become 1, and 1 minus minus 1 raised to n. So this is our an. So the displacement function yxt is sigma n equal to 1 to infinity. This is our an into sin n pi x by 60 cos n pi ct by 60. So this is the solution of our problem. Next problem, solve the boundary value problem. Partial dy square by dt square equal to 4 times partial dy square by dx square. This is our wave equation, and with these two boundary conditions and two initial conditions. Okay, so here c square is given. Here c square is 4, which implies we can take c as 2. Here L is 5 because y5t is 0. That means L equal to 5. And what is f of x? Here f of x is 0 because yx0 is our f of x. What about this 5 sin pi x? This is our g of x. So now everything is not. C is 2, L equal to 5, f of x is 0, g of x is 5 sin pi x. So we know that this is the solution of this problem, and replacing c by 2 and L by 5. So here f of x equal to 0. So ans are 0. You complete this problem, either you can evaluate this integral by substituting g of x equal to sin pi x. Otherwise, here the g of x is of the form sin pi x. From our previous discussion, we know that this is the partial derivative. Then you substitute t equal to 0. So this become right side become bn n pi 2 by 5 sin n pi x by 5. Okay, when t equal to 0, this term is 0. So this is 1, so this become bn. And this is given. Okay, this is equal to 5 sin pi x. Substitute, replacing this derivative by 5 sin pi x, then what happened? Then we get sigma n equal to 1 to infinity bn n pi 2 by 5 sin n pi x by 5 equal to sin pi x. Next we are going to compare the similar terms on both sides. So it is clear that when n equal to 5, this become b5. When n equal to 5, this is 5 pi x by 5, that is, so when n equal to 5, this term is similar to our right hand side. Okay, so by comparing the coefficients, we get b5 into 5 into 2 equal to 5, right? So which implies what? b5 equal to 5 by 2 pi. And what about other bn's? All other bn's are 0. So b5 equal to 5 by 2 pi and all other bn's are 0. So the solution yxt become sin 5 pi x by 5 into b5 sin 5 pi 2 pi 5 pi 2t by 5. So yxt equal to, what is our b5? b5 is 5 by 2 pi. So 5 by 2 pi, and this is sin pi x into sin pi into 2t. So this is the final solution of this problem. These are the homework. Thank you.